So I'm going to start with thousands of years ago, the Mississippi River, before it was constrained by levees and flood control structures, naturally changed course and deposited sediment along what is now our coastline in our delta. But due to human interaction, as I said, we built levees and flood control structures and really constrained the river to one area. And that was to protect cities and farmland from flooding. Well, because of this, we're now losing sediment that built the lands to the deeper waters of the Gulf. As you can see, we've lost a lot of land in Louisiana. The red is what we've already lost, and the yellow is what we've predicted to lose by the year 2050. All of the marshes that are here now are sediment starved and are rapidly degrading. So in addition to human interaction, we've lost land through sea level rise and subsidence, which just means that Louisiana is sinking. But the good news is that we're building land in two areas, the Wax Lake Delta and the Atchafalaya River Delta. In about 20 years, this was built. So where does that leave us? Well, because of this, we have the idea to use river diversions as a major restoration tool. But the problem is that we don't know exactly how the plants will respond to the inputs of the diversions. Diversions divert water, sediment, and nutrients to outflow areas. So my research comes in. I'm trying to aim at helping to close that knowledge gap. So I have a greenhouse study going on where I'm looking at the stressors of nutrients and flooding on 3 fresh and intermediate marsh species. So these 4 images are all one species and representatives for each treatment. You can see immediately that there are differences between the treatments. The ones that experience nutrient elevation, they look a little bit more robust, a little bit healthier, they have more leaves. But the ones that experience flooding, which are these, they're taller, they have thinner stalks, which is evident that the plants were trying to get above the water levels. So this means that they're using more energy to really get above those water levels and produce leaves to stay alive. But this can have negative effects. So if they're producing all of this energy to really get above those levels, it means that they're putting less below ground, which can have detrimental impacts. This means that in the case of a disturbance, they'll have more likelihood that things will go crazy. They'll be unstable. So back to diversions. This means that before we enact these big human interventions to help save our coast, we really need to understand the plant responses and have a really species-specific response or knowledge on the response.